Welcome to qnawire.
All right, in this problem we have a voltaic cell that is constructed with two Zn2 plus Zn electrodes. The two half cells have a Zn2 plus concentration. Let me write that down. So the Zn2 plus concentration is equal to 1.8 molar. And Zn2 plus in the other one is equal to 1 times 10 to the negative 2 molar, respectively. So those are our two half cells. Question A says, which electrode is the anode of the cell? So we want to know which one is the anode. All right, so if you remember, there's a little mnemonic that I use. It's consonant, consonant, vowel, vowel, and that is that reduction occurs at the cathode and oxidation occurs at the anode. And we're trying to figure out which one is the anode. So the anode is the one where oxidation occurs, and therefore we want, since this is the oxidized product, this is what's going to be reduced. We want a high amount of zinc, not a high amount of the product of that. So at the anode is going to be where you have the smaller concentration of Zn2 plus. So this one is going to be my anode. Question B asks, what is the standard EMF of the cell? All right, so remember, so E standard cell is equal to the E naught of the reduction minus the E naught of the oxidation. Well, since the same reaction is happening at both sides, I would end up subtracting the same number. Therefore, the EMF of this is equal to 0 volts. In part C, the question states, what is the cell EMF if for the concentrations given? Okay, so it's not just standard, but for the concentrations given. So for that, we're going to use the Nernst equation, which is that E equals E naught minus 0.0592 volts over N times the log of Q. I don't need to use the one with a different temperature because they didn't say anything about changing the temperature. So let's see. So my Q is equal to the concentration of Zn2 plus for the oxidation half reaction over the Zn2 plus for the reduction half reaction, which is equal to 1 times 10 to the negative 2 molar over 1.8 molar. Therefore, Q is equal to 5.56 times 10 to the negative 3. So I'm going to go back and plug that in here. So I have E equals 0, because that was my E naught, right? Minus 0.0592 volts over, and since zinc is losing or gaining depending on the direction, 2 electrons, that would be 2 moles of electrons here, times the log of 5.56 times 10 to the negative 3. And so for my answer for that one, I get that E is equal to 0.0668 volts. All right, question D asks, for each electrode, predict whether Zn2 plus will increase, decrease, or stay the same as the cell operates. All right, so for part D, which one is Zn2 plus for each electrode? What's it going to increase, decrease, or stay the same? So at the anode, again, at the anode, that is where oxidation is occurring. An oxidation reaction for this is that Zn is going to Zn2 plus. So I'm forming more Zn2 plus. Therefore, the concentration of Zn2 plus will increase at the anode. At the cathode, that's where reduction is occurring. So that's where my Zn2 plus is turning back into Zn. Therefore, I am losing Zn2 plus, and therefore the concentration of Zn2 plus at the cathode is decreasing.